Hello crazy math nerds, it's Kitty Morgan here. This is video 9 of the unit circle, and today we're going to talk about tangent theta. How do we find tangent using the unit circle? So we talked about SOHCAHTOA when we talked about sine and cosine. So now it's time to talk about the TOA part. And so tangent of theta is equal to the opposite. So TOA, that's the last part of SOHCAHTOA, is the opposite over the adjacent. So if we take our unit circle triangle that we have here, the opposite would be y and the adjacent would be x. So to find, you're not going to believe this, to find tangent of theta, you just got to put sine over cosine. Dun, dun, dun. Right? So you can think of it two ways. You can put sine over cosine and put the y value of the point of the x value of the point because they are the same. So if you wanted to find tangent of, we're going to be crazy, we're going to start with one of the quadrantals, of pi over 2, then you would need the sine and cosine of pi over 2. So if you think about that, so I'm going to kind of write sine of pi over 2. You're not going to write this every time, but we're just starting this, so I'm just going to kind of get you used to it. And so again, I'm going to go back to my circle. Here's pi over 2. All right, I do not go left or right to get to this point from the middle. So that is the denominator because that's your x. I go up 1 to get there. Oh my goodness, this scares me. Why do you say that, Miss Morgan? Because there's a 0 in the denominator. And that means that the value of tangent is actually undefined for pi halves. Isn't that crazy? Anytime you have 1 over 0, that is a bad thing. That means you are undefined. How about one of those crazy people around the circle? Let's go with tangent of pi 6. Alright, so that means I need sine of pi 6 over cosine of pi 6. Alright, again, you're not going to write this every time. We're just starting this, so I'm kind of taking it slow. Alright, so again, here we go. Where is pi 6? Pi 6 is a small slice. It's right there. So you go over a lot, and that means the over part is down there, right? Cosine is the over part, and up a little. And so that goes like that. Oh my goodness. We have a complex fraction. So what do you do when you have a complex fraction? You take the denominator and you flip it upside down and you multiply it. Notice that your 2's cancel and you get 1 over root 3. For the unit circle, we really like you to rationalize all your answers. And so in order to do that, let's see, 1 over root 3. We're going to multiply by the magic 1 of root 3 over root 3. And that will give us root 3 over 3. So the tangent of pi 6 is root 3 over 3. Okay, let's see if I can move my camera a little bit more to get in the bottom of this. Okay, so now let's try tangent of pi 4. Okay, I love this one. All right. So this is the best one, the easiest one. We love you. And let me tell you why. Because remember, that's your 45, 45, 90 triangle. Oh, I'm going to do this. I don't want you to think that's the picture of that. So remember, it's going to be the guy that, ooh, that's a terrible circle. Bless my heart. That's the guy in the middle, right? So you go over as much as you do go up. Well, what happens if you put one value over itself? Now I'm going to write this out, and we're never going to talk about this again, right? We know that that's your x and your y, but if you put something over itself, you get 1. So you don't ever show that again. Know that we love pi 4s. Pi 4s has a great sine and cosine because they're the same, and their tangent is just a simple 1. Isn't that great? I love it. It's fabulous. All right, let me change pages real fast, and we'll talk about tangent of pi 3. So tangent of pi thirds. Again, I've got to know where that is. Think about it. It's up here, right? So I need the y value on the top and the x value on the bottom. Now, so I'm thinking that. I'm going from writing it to thinking it. It's kind of how we always want you guys to do. So I go over a little bit, remember that's the over, and I go up a lot, up a lot, up a lot. And again, I'm going to get a complex fraction. It's just the flip of my pi 6 because, you know, they are the same triangle kind of flipped around. So now when I do this, I get root 3 over 2 times, flip that bottom guy, and I get root 3. Yay! That's so fun. Now here's the great thing. All the other pi 6s, pi 4s, and pi thirds have the same tangent as what we just found in the first quadrant. You just got to figure out the signs to figure out what it is. Okay? So just to kind of put all these together. Tangent of pi 6 is root 3 over 3. Tangent of pi fourths is 1. And tangent of pi thirds is just simply root 3. And sometimes if I get confused or whatever, I go, ooh, look, the tangent of pi 6 has 2 3's in it, and the tangent of pi third only has 1 3 in it. And that kind of helps me not get those confused. All right, so what would happen if I wanted the tangent, and we're just going to pick a person, I don't care. How about a 5 pi thirds? Okay, so tangent of 5 pi, and I don't know why I'm writing this so largely, bless my heart. And so tangent of 5 pi thirds, you normally write it lined up. That's okay. I got to figure out where it is, kind of, sort of. So 5 pi thirds is 2 times 3 is 6 minus 1. It's that guy over here. There he is. So to get to him, I'm going to go over a little. Well, wait a minute. I know what the answer is. Why am I doing all this work? I know. All the thirds have the same tangent. And didn't I say it's the one with just the little 3 by itself? Okay, so that's part of the answer. Now I've got to find out, is that positive or negative? Now I need the picture or kind of know where it is. So I'm going to go right and down to get there. So if you put positive over negative, you get a negative. So instead of just one sign, you have to consider both signs. Okay? I'll try to do this a little better. Sorry about that, y'all. 3 pi fourths. It should be looking more like that. I don't know what that crazy stuff is. All right, tangent of pi fourths. We love you. We know you're 1. Oh, yes, we know. You're 1, but are you positive or negative? So now I'm just going to start not making the drawing, and I'm just going to kind of figure out where it is. So I'm just going to kind of like air do it. So 3 pi fourths is almost to 1 pi. So I'm going almost to 1 pi. It's this guy right here. Right? So I have a center. At least I can do that. If this is my center, I have to go left and up, so it's negative. Like I don't have to draw a picture every time. If I kind of know where it is, then I start from the center and I go, how do I move? Left is negative, up is positive. If those are divided, it's negative. All right. How about, we got to do a pi 6, don't we? How about tangent of pi, ooh, I need a pi 6. Let's do, hey, why don't we do 7 pi 6? I love it. All right, every pi 6 is going to have the same tangent. And remember how I said the 6 goes with the, it has 2 3's in it? That's kind of nice. So I know that's part of the answer. Is it positive or negative? Well, 7 pi 6 is, and again, I don't want you to get that confused. 7 pi 6 is over 1. And when I say that, I do need to draw a picture to show you what I'm talking about. Sorry about that. Like this is pi. So 7 pi 6 is over that, a little over, right? 7 is a little bit larger than 6. So I know I go left and down. Well, left and down is negative over negative, which makes that a positive. And remember, I write that for emphasis. I just want you to know I'm really thinking about it. Let's do another, and then I think we'll be done. How about tangent of pi? Well, I know where pi is. It's, and remember, here's me thinking. Here's my think cloud. I'm thinking, oh, that's right there. So I go left 1, that's on the bottom, and I go up none. And what's 0 over -1? It's simply 0. So the quadrantals will have 0 and undefined answers, but all the special angles in the middle will either be √3 over 3, 1, or √3. Well, that's it. That wasn't hard. That was kind of fun. So the hardest thing is that to get the SIGN, and I always spell that out, to get the proper positive or negative in front of the measurement, you must locate it and do the division of the movement, of the X and Y movement, to get your sign. All right, thanks so much.